Alright guys, in lab 12, exercise 20, you're asked to design a loaded voltage divider circuit. A loaded voltage divider circuit is a series parallel application that is specifically designed with load purpose in mind. Capitalizing on Kirchhoff's voltage divider principle of a series circuit, we build parallel circuits off of that, and we split the current proportionately to meet our load demands. So what we have here is two light bulbs. We have two light bulbs that we're trying to drive of different load demand needs. We have a 6-volt bulb that is rated at 200 milliamps. We have a 14-volt bulb rated at 80 milliamps. We're supplying this with a 20-volt source. And so you're asked to figure out what are the resistors necessary to make this circuit function properly. You've been given a list up in the materials list for the lab, which I have posted here on the screen. Your list includes a 220 ohm resistor, a 33 ohm resistor, an 18 ohm resistor, 22 ohm resistor, a 47 ohm resistor, and then of course the light bulbs, the 14 volt 80 milliamp bulb and the 6 volt 200 milliamp bulb. So in approaching this problem and trying to figure out what it is, what resistor is going to need to go where, let's look at the current pathway and how the current splits in a parallel combination. So if we come from the negative end here, the ground end, look at what we know. We know there's 200 milliamps on this branch for this light bulb, and we know there's 80 milliamps on this branch for this light bulb. The sum of those two branches is 228 milliamps. We're going to use a 1/10 bleeder current right here for R3. So 1/10 of 228 is 28 milliamps. So we're going to plan for 28 milliamps going through resistor 3. And then if we consider the sum of those currents as they come together, that 28 milliamps is met by the 200 milliamps coming through the 6-volt light bulb. So now we have 228 milliamps that's going through resistor 2. And that 228 milliamps is met by the 80 milliamps through the 14-volt light bulb. So we now have a total circuit current of 308 milliamps moving through resistor 1. So using those values, the 308 milliamp and the 6-volt desire over resistor 1, we can calculate resistor 1's value. We have an 8-volt 228 milliamp rating across resistor 2. Using Ohm's law, you can calculate resistor 2. And a 6-volt over 28 milliamp rating, we can calculate resistor 3. 8 volts plus 6 volts is our 14-volt supply power for our 14-volt light bulb. So we have that voltage division piece right there. Let's see what that looks like now when we take it to a proto board. Okay, so here I am with a circuit that was put together by student Joey Wagner. This is his assembly. I've modified it slightly to insert some meters in here. Our red meter over here is a voltage meter, a voltmeter, that I'll be probing different locations with. Our green black meter over here is an ammeter that is currently hooked to these white alligators, which is hooked up to our 200 milliamp light bulb, measuring the current through that bulb. And the yellow meter is hooked to our total current at the top of resistor 1 there in the yellow alligator. So that's measuring our total current. When you look at that, we've calculated our total current to be 308 milliamps, and we're currently seeing 309 milliamps. So we're pretty close to what we calculated are expected to be. If I probe my source voltage here, I should see that I have exactly 20 volts that I'm working with at my source. Now let's actually look, see what's going on here when we probe the voltage across resistor 2, I'm sorry, resistor 1, I guess this is resistor 3. Across resistor 3, we are seeing 6.8 volts. That basically is the voltage at DS1, 6.8 volts. Okay. When I probe the combination of resistor 2 and 3, so we're looking at the voltage across DS2, we're seeing 14.2 volts. So pretty close to what we wanted or desired here on our total output. When I look at the actual current that's flowing through our light bulb, this is our 200 milliamp light bulb. It's seeing 173 milliamps. Remember, 200 milliamps is a max rating that we can plan around. So we're able to see that pretty much this circuit is functioning as we had hoped it would. Now, what resistors did Joey choose? What did he put in place here? He has a brown, gray, black for resistor 1. That would be an 18 ohm resistor. He has an orange, black for resistor 2. That's the 33 ohm resistor. And he has a red, brown for resistor 3. That's the 220 ohm resistor. Now, these resistors are not exactly the calculated values. You're going to have to make some adjustments around standard resistor values to be flexible with the circuit to make this work. But here we're able to prove that we can purposely design a circuit to function and support two different voltage needs within the overall circuit. And that's the benefit here of a series parallel circuit. Specifically, we're talking about a loaded voltage divider, where those loads are our light bulbs. Okay, good luck.